Hello, ladies and gentlemen. Chapter 22, day 2, the two proportion Z test. Okay, and essentially, after today, that is what chapter 22 is. It's the introducing you to the two proportion Z interval and the two proportion Z test. And as I told the A cohort students yesterday, um, these chapters move a little bit quicker now because we've already established all of the fundamental concepts of a confidence interval, and we've already established all of the fundamental concepts of a test. So now all we do is we just introduce you to a new test and we introduce you to a new interval. Okay, that's how this is going to work for the rest of the course. Um, so there's still going to be questions. All right, you made a decision. If it's the wrong decision, is it type 1 error? Is it type 2 error? So all of those questions are going to still continue to come up again and again and again. Um, we're going to calculate p-values, and we're going to make decisions the same way. If your p-value is less than your alpha level, you reject the null and accept the alternative. So a lot of what you're going to see today is very, very, very similar to what you saw with the one proportion Z test. Okay? So here we go. With the recent, now this was actually like last year or 2 years ago I did this, so it's not as popular anymore. But with the recent popularity of the Impossible Whopper, maybe you remember this from like a year, I think about 2 years ago, served at Burger King, and the Beyond Burger sold in grocery chains. A Gallup survey conducted between September 16th and 30th, 2019, so yeah, about a year and a half ago, asked a random sample of American adults, have you personally tried any plant-based meats or not? In addition to their response to this simple question, they also gathered information on each person's gender, race, age, education level, political party affiliation, ideology. So this is real data. I looked this up, by the way. The survey found that 295 out of 832 conservatives, people who identify themselves as being conservative, and 286 and 584 liberals had in fact tried plant-based meats. Does this data provide evidence that the proportion of liberals that have tried plant-based meats is significantly higher than the proportion of conservatives? Okay, so step one, just like we saw yesterday, and just like we do with the one proportion Z-test, is to identify our parameters of interest. So what we're looking at here is the proportion of liberals and the proportion of conservatives that have tried plant-based meats. So parameter L, proportion of liberals that have tried plant-based meats. I myself, I've never had an Impossible Whopper. I don't even know if Burger King still has it. Now, I don't eat fast food very often, and I've never had a Beyond Burger or any of that kind of vegetarian meat, so to speak. So no, I myself have never tried that. So then we have the proportion of conservatives that have tried plant-based meats. Okay, so just like we saw on day one, you identify your parameters. Now, the hypotheses are kind of sort of similar to a one proportion, except we're comparing these, okay? So the null hypothesis, once again, is the idea of equals. But in this case, the null hypothesis is that the difference between these two population proportions is 0. In other words, there is no difference, all right? I'm not going to write that one first. I'm actually going to write the alternative first, and here's why. The alternative wants to answer the question, does the data provide evidence that the proportion of liberals that have tried plant-based meats is significantly higher than the proportion of conservatives? So we want PL to be greater than PC. Now, in terms of subtraction, that would mean that PL minus PC is greater than 0. That's the alternative. And the reason why I did that one first is because I wanted to set this up with PL minus PC, because then the null is that PL minus PC is equal to 0. So the null is always that the difference is equal to 0. Okay? The alternative is that the difference is greater than 0, less than 0, or not equal to 0. So you pick it the same way you did with the one proportion, based upon the wording of the question. All right? So the null for a two proportion will always be that the difference is 0, and the alternative will be that the difference is either greater than 0, less than 0, or not equal to 0. Okay? And you want this to stay consistent. Whatever you have here, if you have liberal minus conservative, you want to stay consistent with liberal minus conservative. If you want to like switch these, like here, not just to get wild and crazy, you say, well, Mr. Johnson, what if I do this? That would be 0, but then you would want PC minus PL to be less than 0, and that's how you'd have a less than test. All right? Because if you're going to switch those, well, then you would want this to be less than 0. Now, I wouldn't want to do that test. I like to always have a positive difference. Okay? So we're going to stick with this one. Now, the assumptions and conditions are the exact same thing we saw yesterday. The exact same thing. So we have random sample of 832 conservatives and 584 liberals. So we have random sample of 832. I already lost track. 832 conservatives, and 584 liberals. We will assume independence within each political group. Okay. And the one new thing I added yesterday is that we assume independence between the two political groups. Okay? So this was the new thing I added yesterday. It's independence within the groups and independence between the groups. So there's two levels of independence there. Now, among the conservative group, let's make sure we have at least 10 successes and 10 failures. Among the conservative group, we had, let's see, 295 said they had tried it, and 832 minus 295 would be 537. So 295 said yes, they have tried, and 537 said no. And among the liberal group, we had 286 said yes, and 298 said no. So 286 said yes, and 298 said no. Okay? So these are the exact same conditions you checked with the two proportion interval. No difference whatsoever. Do you have two random samples? Are those random samples independent of each other? Can we assume independence within each of those samples? And within each of those samples, do you have at least 10 successes and 10 failures? And as long as all of that is met, we do a two proportion Z test. And this is why the name is so important, because now when we start mixing in one proportion stuff, oh no, you got to be able to read the question and say, okay, is this a one proportion Z test or is this a two proportion Z test? And you identify the test that you're going to do. All right? Okay, so we have two parameters. We have a null hypothesis that there's no difference between those two parameters. And we have an alternative that the difference of PL minus PC is greater than 0. All right. What is our sample statistic? Well, let's see. P hat for the liberals is 286 out of 584. So 286 divided by 584. 0.4, oh, yeah, say 0.49. P hat for the conservatives was 295 out of 832. So 295 divided by 832. That's about 0.355, we'll say. Okay, let me double check that real quick because I was just looking back at my calculator. 295 out of 832 and 286 out of 584. Good. So just like yesterday with the two proportion interval, we're not going to focus on either one of these individually. We're going to look at what we already set up as the difference. Now this follows from our alternative. We're going to do L minus C. So liberal minus conservative is 0.49 minus 0.355. So we have a difference of 0.135. So the question becomes, is this difference significantly larger than 0? That's the question. Is this difference significantly larger than 0? That's the question. So if we assume there is no difference in the proportion of conservatives and liberals that have tried plant-based meat, then what value is the center of our curve? Well, the center of our curve is our null hypothesis. The center of our curve is 0. And the question is, what is the probability of getting a sample difference of 0.135 or more? What is that probability? That's what we got to figure out. Is that probability something very, very small, say less than 0.05? Or is it not very small? Is it something bigger than 0.05? Then, what value do we assume is the true proportion of each group if we are assuming there is no difference? Okay. Now, this is the one new thing that we do in this test that's different than what we did yesterday. We're going to calculate something that's called p-hat pooled. Okay. Now, the null hypothesis is the idea that there is no difference between these two population proportions. The problem is we have two different p-hats, but everything in the calculation has to be based upon the assumption that there's no difference. So we need a value that represents the population proportion for liberals and conservatives. And this value is called p-hat pooled. And what we do is we take the total number of successes, which is 286 plus 295. We divide it by the total number in the sample, 584 plus 832. In other words, we had 286 plus 295, 581 successes out of 585 plus 832, 1,416 people that were sampled. So 581 divided by 1,416 is 0.41. So this is the value that we're going to use to calculate our standard deviation. So what we do is, all right, follow along with me here. The standard deviation, yesterday we saw p-hat for the men, q-hat for the men, sample size for the men, plus p-hat for the women, q-hat for the women, sample size for the women. Now when we do the test and we're calculating a p-value, we say, all right, I'm going to use 0.41, 0.59 over sample size for the liberals, 584, plus 0.41 times 0.59 over sample size for the conservatives. And so we can punch this all into your calculator at once. You can literally punch in square root 0.41 times 0.59. You don't need any parentheses whatsoever. Divided by 584 plus 0.41 times 0.59 divided by 832. And the standard deviation value is 0.0266. Okay? So what we want to get is, what is the probability of getting, hold up, a p-hat liberal minus conservative greater than 0.135? That's what we want to figure out. So the z-score is our value minus the center of the curve, which is 0, divided by our standard deviation value, 0.0266. So really 0.135 divided by 0.0266. Holy cow. 5.075. Now, right now, you'd be like, wow, that's really far above the curve. That's really far above, above 0. So, p-value, normal CDF, from 5.075 to 99. Basically, you're going to get 0, okay? It's not officially 0, but it's practically, for all intents and purposes, 0. So 1.9 times 10 to the negative 7. In other words, it's about 0. Okay? How are we doing on time? All right, not too bad. All right. So you want to check your work, right? You want to make sure you did this correctly? All right, let's make sure we did this correctly. So go to your calculator. Okay. We're going to go to stat. We're going to go to tests. We're going to do 2 proportion z test. Right there, option number 6. Hit enter. All right, I have all the stuff in here from yesterday. So we want to put in the liberal data first. So for our liberals, I got to back up on my calculator to see this. So for the liberal data, we had 286 out of 584. For the conservative data, we had 295 divided by 832. And our test is that, okay, we got to think about this, that the proportion here, the liberal proportion, is greater than the conservative proportion. So we want to choose this option over here. Oops, I didn't hit that. Enter. And if you hit calculate, okay, I'll give you a second. So we have the liberal, 286 out of 584, conservative, 295 out of 832. The liberal greater, P1 greater than the conservative. And here you go. Like, holy cow, what's going on here? So there's our z-score. That matches what we had. There's our p-value. That matches what we had, that really small p-value. P-hat for group 1, that was the 0.49 for the liberals. P-hat for group 2, the 0.355 for the conservatives. This here, this is that p-hat pooled value, that 0.41. That's the value that we use in the standard deviation calculation. All right, that's the one really key thing about today is this whole p-hat pooled value. So that's what that is. Sample size for group 1, sample size for group 2. There you go. That's how you check your work. So we make decisions the exact same way. P-value, about 0, less than alpha equaling 0.05. Reject the null. Accept the alternative. And we describe the alternative in context that a higher proportion of liberals have tried plant-based meats. And there you go. That's the two proportion z-test. If we had failed to reject the null, you would say we failed to reject the null, that there's no difference in the proportion of conservative and liberals that tried plant-based meats. I'll say that again. If we had failed to reject, you would say we failed to reject the null, that there is no difference in the proportions. Here, when we accept the alternative, we're saying there is a difference. And the difference is that the proportion is higher among the liberals. All right? Now, if our data led to the wrong conclusion, don't think it happened. We had a very, very small p-value. But remember, if we reject the null and we accept the alternative, there is a possibility of type 1 error. Okay? So those same conversations are still going to be had. So that's it, guys. That is essentially what you need to know for chapter 22. It's here's the two proportion interval, here's the two proportion test. So now it's really just practicing this, getting used to how they're set up, getting used to the fine little changes. That the big change for today, the big thing for today is this right here. Okay? Because it's not the same as what we did yesterday. In the interval, this would have been p hat for the liberals, q hat for the liberals, and sample size for the liberals. Here, this would have been p hat for the conservatives. That's not supposed to be 0.832 there. This would have been p hat for conservatives, q hat for conservatives, and sample size for conservatives. So the key thing to recognize is that this calculation is different for the test when compared to the interval. The test uses this p hat pool value, the interval does not. So only used for the test, not the interval. Okay? This is the one kind of hiccup in this chapter, is this whole p hat pool thing. All right? And the reason why we have this is because our null hypothesis is assuming there's no difference. So we need a value to represent the true proportion for liberals and the true proportion of conservatives, and we need that value to be the same thing. And this is what that value represents. So for the sake of the question, we assume that the true proportion for each group is 0.41, and that's why we plug it in both spots. All right? So if you have questions, by all means contact me. Other than that, I'm done. Thank you for tuning in. Have a fantastic day. Thanks, guys.